This is a CA January 13 paper question. So it's talking about ball bearing is propelled up a 3 meter long frictionless ramp. So the whole thing is 3 meters. It is released with initial velocity of 3.6, okay, at this point above the bottom of the ramp. And it reaches a maximum distance of 2.6 in the foot of the ramp. Right, so that's the maximum distance it travels from here to here. Show that the deceleration, so its deceleration, A, is going to be a negative number of the ball is 5.4. Okay, so let's see what we know. We know its initial velocity is 3.6, so U is equal to 3.6. It reaches a maximum distance of 2.6. Now, if you wrote down your distance travelled as 2.6, that would be wrong, because remember the ball is starting 1.4 meters up from the bottom of the ramp. So the distance travelled, symbol S, is equal to the difference between these two distances. So it's 2.6, take away 1.4, obviously giving you a distance of 1.2. So S is equal to 1.2. And if that's the maximum distance, we know at maximum distance it's obviously stopped travelling. So our final velocity there, V, is equal to 0. And we want to find A. So let's look here at our equations of motion. And we have U, S, V and A. So what one links those two? It's going to be this one here. V squared equals U squared plus 2AS. Need to rearrange the equation to get A. So at the minute A is being multiplied by 2 and S, I'm going to ignore that. It's also being added on to U squared. That's the easiest bit to get rid of first. So if it's being added on, we'll have to do the opposite to get rid of it. So we need to take it away from this side and also take it away from this side. So V squared minus U squared equals 2AS. Now again, now we can look at this here, getting rid of the 2 and the S. So A is being multiplied by 2 and S. To get rid of that, we have to do the opposite, which is divide. So we're dividing this side by 2S, we have to divide this side by 2S. Squared minus U squared over 2S equals A. Now all I'm going to do then is just put in my numbers. So V 0, 0 squared 0, take away U squared, 3.6 squared, divide it by 2, so that's our equation, times S, which is 1.2. Now remember, because it's decelerating, our value for A is going to be negative, and that's proven by this here, the negative sign here. So when you do that, you will get your answer to be minus 5.4. So that's just showing you your acceleration is negative. So our deceleration is positive. So there we go, we've proven that. This one here, it is calculate the distance of the ball bearing in bold. Now if it's in bold, it means it's a hint and it's also 4 marks, so it's slightly harder than our average question. Calculate the distance of the ball bearing from the foot of the ramp after 1.6 seconds. So we obviously know it didn't even start at the bottom of the ramp, it started at 1.4 meters up. So we're going to need to find the time it is or the distance that it has travelled after 1.6 seconds. So we know our time, 1.6. What else do we know? We know at the start it had an initial velocity of 3.6. We also know that it is a deceleration 5.4. So remember, if it's decelerating, A is going to be negative. And we want to find S. So looking again at my equations of motion, I have T, U, A and S. Which one links those two? Those four, sorry. This one, S equals UT plus a half AT squared. So we're going to rearrange this. No, don't need to. Just put in our numbers. 3.6 times by our time 1.6 plus a half times, remember your A is minus, so put it in. 0.4 times, we have to square RT 0.6 squared. So whenever we multiply this out, we will get 5.76 for this part. This is going to be a negative number because A was negative, so it's going to be minus 6.912. So 5.76, take away this number, is obviously going to give us a negative number of minus 1.15. Now at this stage of the game, if you've gotten here, well done, you've got 3 marks out of 4. Now this is saying it wants to calculate the distance from the foot of the ramp. Now we know it started 1.4 meters up. Okay, any distance up here, so any distance will be positive. What we've got here is we've got negative answer, or negative distance, and all that means is that it's obviously the ball is now travelling in a different direction. So the ball is somewhere down here where distance is negative, and it started 1.4 meters up. So this is where it is. We're just going to take our 1.4, so remember that's how far up it started, and add that on to our minus 1.15, and we will get the distance from the bottom of the ramp being 0.25. So all that minus sign is that it's changing direction. The last part of this question is, on the axis below, sketch the velocity time graph for the motion of the ball bearing during 1.6 seconds. Okay, so we know it is velocity, its starting velocity is 3.6. As soon as it goes below the x-axis here on a velocity time graph, it just means the object has changed direction. So because our answer here was negative, we know at some stage during the 1.6 seconds the ball has went up, and then it's changed direction and started falling down again. So it's now, say that was 0.25 meters. That is where the ball is at 1.6 seconds. So all we have to do is you need to be able to say that you know that your starting velocity, so your graph is going to start from here. It has to change direction, and because it's only talking about the time to 1.6 seconds, we have to stop our graph here. So I'm going to say it's an alpha straight line. This is where I've started. It's going to change direction somewhere we haven't marked it out, it hasn't asked us to, and it's finishing there. So it's a straight line. You could, depending on what way you took your initial velocity, you could use your minus 3.6 and draw exactly the same shape and just stop it again at 1.6. It does not matter. Okay, because remember this minus sign just means it has changed, it's a different direction compared to this one.